For an example of the integral test, I would like to pose the question, is the series sum from n equals 1 to infinity of n times e to the negative n convergent or divergent? So the first thing I'd like to do is consider the generating function for this series, x times e to the negative x. The graph of this function looks approximately like this. It would be relatively straightforward to show that the critical point for this function occurs at x equals 1. Therefore, on the interval from 1 to infinity, the function is positive, decreasing, and continuous. Therefore, we are allowed to use the integral test for this. So if we can determine the convergence or divergence of the following integral, we will be able to determine the convergence or divergence of the given series. Now, in order for us to do so, first we express our improper integral in terms of a limit. This will be the limit as capital T approaches infinity of the definite integral from 1 to t of x times e to the negative x dx. In order to integrate this, we will be making use of parts. We'll let u equal x, dv will be equal to e to the negative x dx. Differentiate u with respect to x, we'll get dx, and integrating dv with respect to x, we'll get negative e to the negative x. So according to the integral by parts formula, this will be the limit as capital T approaches infinity of u times v minus the integral of v du. This part of the integral has already been evaluated, but before we start plugging stuff in, we'll go ahead and finish our integral over here. Now we do have minus a negative, which should become positive, but the integral of positive e to the negative x will wind up giving us another negative, as was indicated over here when we integrated e to the negative x prior to this. Plugging in these limits of integration, we will get the limit as t approaches infinity of negative t e to the negative t minus e to the negative t minus negative 1 e to the negative 1 minus e to the negative 1. To evaluate the limit as t goes to infinity, this is simply an exponential decay and will go to 0. This is an indeterminate form, so as a quick aside, if I try to plug in t equals infinity, plug in, since we can't really plug it in, we would wind up with infinity times 0. So for that, we will force a fraction. Limit as t goes to infinity of negative t e to the negative t will be equal to the limit as t approaches infinity of negative t over e to the t. One application of L'Hopital's rule gives us that this will be the limit as t goes to infinity of negative 1 over e to the t. This is the same as this limit, which we already stated will go to 0. So we wind up with 0 minus 0 minus negative e to the negative 1 minus e to the negative 1. This number is 2 over e. I do not care what the value of that number is. I care that we actually got a number. So the improper integral converges. Now, according to the integral test, because our function is positive, decreasing, and continuous, and because the improper integral converges, that lets us know that according to the interval test, the series converges as well. I'd like to get us into a habit of how we state our final answer. The 3 triangles is the mathematical symbol for therefore. By the blank test, the series blank blanks. These are 3 blanks that I would like to see filled in for every single one of the problems here forward. Now we're going to be learning lots of different kinds of tests, but the big one that we need for right now is that according to the integral test, the series that we had at the beginning of the problem, n equals 1 to infinity of n times e to the negative n, converges. All of our final answers for Chapter 11 questions should be in this form.